Alright, so today we are doing section 8.4. It's all about area of a triangle or area of triangles. So our goal today or our objective is to find the area of triangles. There's basically one formula we're going to use today. Here it is. You need to write this in your notes. This is very, very, very important. The area of a triangle is 1/2 the base times the height. And the important thing to know is that the base and the height are perpendicular to one another. So they form a right angle. So for example, if you're looking at this triangle and they give you this side length over here, that can't be the height because it doesn't form a right angle with the base. So they'll always give you a few different side lengths here. One of them will be the height, so you have to know which one's which. Usually they only give you two, so it's usually pretty easy. But just so you know, the base and the height have to form that right angle. The other hard part of this section is knowing how to type it in the calculator. So you guys know the ABC button? You can do 1 ABC 2 times the base times the height, or you can do 0.5 times the base times the height, or you can do the base times the height, hit the equal sign, and then divide by 2. It'll give you the exact same thing. So a lot of today will just be figuring out, well, what's the base, what's the height, and how do I type it in my calculator? Any questions? Alright, so we are using that formula on both of these. Area equals 1/2 the base times the height. Base and height form right angles. So in number 1, it looks like that's exactly what they gave us because this 12 and this 5 come together to form this right angle. So that is the base and the height. So I'm going to do 1/2 times 12 times 5. Again, you can do 1 ABC 2 times 12 times 5 equal sign. You can do 12 times 5 equal sign. Divide by 2. You can do 0.5 times 12 times 5. These will all give you the same answers. Does anyone have the answer for me?
Well, 12 times 5 would be 30. Yeah, 30.
12 times 5 is 60, and half of 60 is 30. So the answer is 30. Good. We're still talking about area. So square inches. Very good. Another way to think about it, they said 12 times 5 is 60 and half of 60 is 30. You could do half of 12, which is 6, and then 6 times 5, which is also 30. It just kind of depends how it makes sense to you. Alright, same thing on the next one. We are given the base and the height again. They're coming together to form that right angle, so I know those are the correct measurements that I'm looking for. So 1/2 times 4 times 8. Yeah, this is going to give you 16, and we're talking about centimeters, so square centimeters. Please practice with us on whatever calculator you're going to be using when you're doing your homework and your quizzes and your tests. The hardest part is knowing how to type this in correctly. Any questions? Alright, you don't have to draw these, but please do the work with me. So for example 3, we have area equals what?
Area equals 5, 14.
There's a 5 in it, there's a 14 in it, and yes, you're missing the 1/2. So area equals 1/2 the base times the height. In this case, I think we put the height times the base. That's fine. Remember, multiplication is commutative. The order doesn't really matter. 14 is an even number, so I would probably do 1/2 times 14, which is 7, and 7 times 5 is, yes? 35. Good. Thank you for sharing. All right, example 4. What am I typing in?
8.
There is no 8 on example 4. That's a 6. So area equals what?
A half
1/2
times 6 times 9.
times 6 times 9, or times 9 times 6.
27.
You should get 27. Any questions on the formula or how to type it in or where I'm getting these numbers from?
It's super duper easy.
Super duper easy. I was hoping you'd say that.
You guys are gonna master this.
Just like when we were talking about area of a rectangle, now we're going to do the problem sort of in reverse. I think they're equally as easy. As long as you write everything out, don't try to shortcut yourself. That's when you really mess up. I want you to pick one of these and draw the matching triangle. So for one of the examples, you can just do the work. For one of the examples, you need to write the problem, draw the diagram, and do the work,
Why?
so that you have one good example to refer back to when you're doing your homework.
It's easy. We don't need to worry
All right, still using that area equals 1/2 times the base times the height. What is the area in example 5?
15.
So instead of the A, I'm going to put 15. Equals 1/2 is still 1/2. What's the base?
10.
10. What's the height?
10. No.
H. Very good. The easiest way to do this is to simplify what's going on right here. What is half of 10?
5.
5. So I have 15 equals 5H.
You
Divide
do
both
all that.
sides by 5. And what does H equal?
3.
3.
Oh.
Because I divided both sides by 5?
Yeah, you're right. I multiplied it.
6.
Yep, that'll get you. You can sort of check your work though, because like if you put the wrong number in here, and then you go and check, well, is 1/2 times this one, and then you wouldn't get the 15. So you can kind of check it as you go. All right, next one. What's the area?
We're going to draw the figure, right?
You can draw the figure of one of these.
That's not fair.
Would you like to do both?
You mean it's not fair to the other triangle?
If you're worried about the feelings of one of the triangles, you can definitely draw both. I'll give you another minute. All right, what's the area on number 6?
Let's see, Dave.
What is it? Area on number 6, guys.
26.
126 equals 1/2 times what? Focus.
You guys are
1/2 times?
Oh, 1/2 times B.
B times?
Times A.
We already have the A. A is
Times
126
12.
times 12. Good. Now, you can do 1/2 times 12, even though they're right next to each other. Remember, order is not super important in multiplication. You can rewrite them in any order. So what is half of 12? 6. So on the right side of my equation, I have 6B. Divide both sides by 6, and what does B equal?
100. No.
Do some long division. What's 12 divided by 6? 2. What's 6 divided by 6? 1. 21 is the answer. Look at you. Long division in your head.
That's fun.
Raise your hands if you have any questions. Alright, so on the board you will see the theorem for today that has to do with area of similar polygons. So we talked about similar polygons in the last chapter. We wrote scale factors for them. Remember, scale factor is just the ratio of the sides simplified. So for example, if you have a scale factor A over B, and I ask you to find the ratio of their areas, you would just square the top and bottom of the scale factor. So example 7 goes right along with this theorem. It says to find the scale factor of these triangles. Remember, order matters in scale factor. They want the scale factor of triangle DEF to triangle ABC. So here's triangle DEF. Someone give me a length from DEF. Doesn't matter which one. There are two numbers on the board. Say one of them.
6-3.
Pick one of them. 6. Okay, so we're going to go with 6. So on the top of my scale factor, I'm going to write 6. We want the scale factor of this triangle to this triangle. So which side corresponds with the 6 in triangle ABC? Which one's in the same position as the 6?
10.
The 10. And then we can reduce that to give us 3 over 5. So if you would have picked the height, the 3 or the 5, or the 3 and the 5, you would end up with the same scale factor. What we just did is not new. This should be something you can do pretty quickly. It's what we did last chapter.
Just one hole.
Huh?
The new part is what we're going to do next. If I want the ratio of their areas.
Folks, come.
So if I want the ratio of their areas, what do I do with the scale factor? It's written right here.
Divide.
Where do you see divide?
I see what, okay.
No, you square them.
Yeah, you square them. So this is like the A, this is like the B. I guess I see where you said divide. Okay, I take it back. I take it back. All right, but yes, we are going to square the top, square the bottom. What is 3 squared?
9.
9. Very good. What is 5 squared?
25.
25. Good. I shouldn't really put an equal sign there because they're not really equal. So again, if you have the scale factor and you want to find the ratio of the areas, you just square the top, square the bottom. If you don't have the scale factor yet, you have to set it up. Remember, the scale factor is just the ratio of the side lengths simplified. So depending on what information they give you, that's how you set these problems up. Any questions?